Hello, my Algebra 2 students. We are starting a new unit. Unit 6 is all about quadratic functions. So this is what your note packet looks like, but when you open up your note packet, you're going to see the first outline that shows that day 1 has little parentheses around it. We're skipping it. Just because it's an overview, we used to do it on like a half period. We can skip it. What we're going to hop right on into is actually some factoring, and specifically, we are going to be factoring what's called sum and difference of cubes today. So new factoring. And then you can kind of see we do have a quiz in the unit. That's going to include complex. And then later on, we'll hit a test. Right? There are not many notes that are pre-printed. So like this goes into a review of factoring methods. That's because most of this unit is going to be take your own notes. So right now, what I need you to do is go find some paper that you can have for our note taking for today. Feel free to pause the video if you need to. Otherwise, I'm going to zoom in. We're going to jump right in actually with a warm-up today. Right. So like I said, we skipped over officially day 1 so that I don't confuse anybody. We are going to start by calling this day 2 notes. Right. And we are looking at factoring. All right, let's start with a warm-up of multiplying to kind of remind ourselves how we work one direction before we work the other. So if I ask you to multiply this out, x plus 2 and then times x squared minus 2x plus 4. All right, way back in unit 1, we know how to multiply all this out using box method typically. It's basically a fancy old way to double distribute. But I think it's a good way to do it. So if I go over here, if I go x plus 2, and then give myself some space, x squared minus 2x plus 4, we can work our way all the way through this. So this would give me x cubed minus 2x squared and plus 4x. If I multiply everything here by the 2, I'm going to get 2x squared, positive there, minus 4x, and then plus 8. When we go to simplify all this, we get an x cubed here. This is a plus 2x squared and a minus 2x squared. Those are going to cancel. Plus 4x minus 4x, they cancel. And then all you're left with is a plus 8 right here. This is going to be important to look at in just a couple of minutes. All right, now let's talk about what are some of the factoring methods that you should know going into today. Well, GCF, we said, is what you always look for first, so greatest common factor. Difference of perfect squares. And I tend to just draw it with a little square there. There's the trinomial factoring, which is the whole like add, multiply guy. And then we did also learn back in unit 1, the use of dummy variables. It's not a method of factoring, but it's a way to help you recognize what type of factoring you're looking at, right? What we are going to be looking at specifically today is a little bit of practice of all of this, and then also one new method. So let's do a little practice first. Kind of get our brains in the game here. First one, if I give you 20a squared b minus 5ab squared. What I'm hoping is as soon as you get that written down, they're like, there's GCF going on there. We can take out between 20 and 5, we can take out a 5. Between the A's and B's, we can take out a single A, and it looks like a single B. So you can always treat it as if you're dividing by that GCF, right? But when we go to show the answer, the GCF comes in front, and then we are left with whatever the quotient is from each little piece. So this would then be 4A. The 5s would cancel, A's would cancel, just a single B there. Remember, when you're factoring, the idea is that if you were to multiply this back out, you would get right back to where you started. So if I redistributed this, I would come right back to the original. Right? For the second one, if I give you x to the 4th minus 16, All right, well, no GCF this time. Difference of squares, 16 is a perfect square, and actually any variable with an even exponent, that is also a perfect square. So if I think about taking the square root of x to the fourth, that would give me x to the second. The square root, of 16, that would give me 4. So when you think about how we would build these difference of squares, you take the square root of each, square root of the first piece goes in the front half, square root of the second piece goes in the back half, and then 1 plus, 1 minus. If it can keep going, we want to keep it going. This is difference of squares again. So I'm going to keep the x squared plus 4, and then this will split to x plus 2 and x minus 2, because that's the square root of x squared, that's the square root of 4. When you've completely factored it, then we can stop boxing in and call it a day. If we go one more, I'm going to give you x to the 6th power plus 3y cubed minus 40. Oops, I'm so sorry. A little bit of a brain fart there. I wrote a y, I meant an x. Let's fix that. I don't want to confuse you with that. There we go. Okay, so when we're looking at this part of it, when you look GCF, no. There's more than 2 terms, so it's not difference of squares. So what we have here is a little trinomial factoring. Sometimes the little hint to help you see it better is take the exponents down and make it x squared and then plus 3x minus 40. In that case, we can see that this is just an add multiply. So what multiplies to 40 adds up to 3? Well, hopefully we'd recognize that would be 8 and 5. It would be plus 8 minus 5. For this one, it would go x and x. To make it match this guy, you just have to think, what would the powers on x need to be so that when I multiply it together, I get that x to the 6th. And in that case, if you can remember, when you multiply the bases, you add the exponents. So x cubed and x cubed will do it. And then I'm going to have my minus 5 and my plus 8. Right? Just like the last one, you should always look to see, can it keep going? Well, this is what our focus for today is going to be. If you look, x cubed plus 8, that was actually the answer that we got from multiplying out these pieces here. And we said, if you can multiply something back out to get the original, that means that what you had is a correct factored form. So what we're going to talk about today is, how do you recognize going from here and factoring back to something like that? So I'm going to write ourselves a little note down here, because otherwise you might be like, where did we get this? So from the warm-up, we recognize that this is going to factor down into x plus 2, and then x squared minus 2x plus 4. And then we would bring this piece of it down, the x cubed minus 5. This piece of it actually cannot factor any further. So that's as far as that part's going to go. But that's going to intro us into our new method of factoring, which is sum and difference of cubes. And I write it as sum slash difference just because there's the sum of cubes, and then there's the difference of cubes. So there's actually 2 different methods, but they're super, super similar. All right. So what I'd like to do, for me, I'm going to hop on over to another page because I'm kind of out of room here. All right. But let's talk about, how the heck do you get from here back to here in any sort of organized way? So let me slide my papers back on up here. All right. Well, let's take what we had. We had x cubed plus 8. And we know that that ends up being equal to x plus 2, and then times x squared minus 2x plus 4. All right. Well, for a couple of things, this right here, we know that there's 2 terms. So that's something that we'd want to be able to spot. Each term is a perfect cube. Because x cubed is literally x being cubed. 8 is 2 being cubed. All right, and in this case, the terms are being added. So that means we're focusing on the sum of cubes for this first guy. All right. So what's presenting itself over here? Well, let's look at the second piece of it. All right. So I'm going to kind of break this up. For the second part, I'll put a little arrow over here. Right. It factors into the first part is a binomial, just meaning two terms, and then times a trinomial. Might be making up a little spelling there. All right. In the first parenthesis, there's a couple of things. Well, x and 2, those are actually the cube roots of what you're seeing over here. Right? As for what comes for the second part of it, it's kind of a combination of taking those values and squaring and multiplying and so on. So let's actually organize what's happening in each piece of it. All right. So the steps for factoring the sum of cubes. So that's to get this side of it. All right. For the binomial, what we're going to do is take the square or take the cube root of each term. All right. And so in this case, that would be the cube root of the x cubed and the cube root of 8. And so make sure to put the little cubes up there. All right. That came out to be x. That came out to be 2. That goes into the binomial then, the x plus 2 piece of it. For the second part of it, for the trinomial, right, you end up with 3 terms there. You have the x squared, you have the minus 2x, and you have the plus 4. All right. Well, to get the x squared piece of it, or the first term, you're going to square the x here. So the first thing is you square whatever the first term was. So that produced the x squared. The middle term is you multiply together the 2 terms. So the x and the 2, when you multiply them together, that gives you the 2x. And then the third part of it, you square the second term. All right, what I mean by that, the 2 is the second term here. When you square 2, that gives you the 4. So that's where you can see all 3 of those pieces there. And that turns into the x squared and then the 2x and the 4. Now, the only part that might not be obvious is how do you do the signs? So if you look up top, the signs were minus here and plus here. So for the signs, we can write ourselves a rule. The signs are always plus in the first parenthesis and then minus plus in the second parenthesis. So that's how it's going to line up here, right? And so what we can do is kind of write ourselves in general. If you have, oops, I don't need that first parenthesis there. If I have x cubed plus y cubed, in the first parenthesis will be the cube root of each, so x plus y. In the second one, it'll be this first part squared, so x squared. The product of the 2, xy. And then the last part squared, y squared, where it goes plus and then minus and then plus, right? So that's going to be what it should look like. What we're going to do is a little bit of practice so that we can kind of see how this lays out. All right. So for this next one, let's give ourselves some examples for some practice. I'm going to give you, excuse me, right, y cubed and then plus 64. So when we do this, what I want you to think of is what's the cube root of each one. So the cube root, and you can do it off to the side, you can do it wherever. So the cube root of y cubed is y. Oops, the cube root of 64. If you're not sure, grab your calculator. As a little reminder, it's helpful to know where that cube root button is. It's under the math key. and then go down to choice 4. So the cube root of 64, and that comes out to be 4, because that literally means 4 times 4 times 4. That gives us 64. All right, so how that breaks down then is that we're going to have y plus 4 in the first parenthesis here, and then in the second part of it, it's the first part squared, so y squared, the product of the two, so 4y, and then the last part squared, so 4 squared. And since this is plus, this goes minus, that's plus there. All right, if I then clean this up, because I probably wouldn't leave my answer looking like that, I'd probably leave it as y plus 4, and then y squared minus 4y plus 16. And there you go. So if we do it where there's slightly more complicated values going on here, you might have variables and numbers mixed together. So for this next one, if I give you 125 and then plus 27 x to the 6th, you'd still have to look at this and go, okay, what is the cube root of each part? And again, do it off to the side, do it underneath. Maybe I'll do it right here this time. So the cube root of 125, and then I need the cube root of 27x to the 6th. Ooh, all right, cube root of 125. Our calculator can do that piece for us. So there we go. If we type that in, that gives you 5. The cube root of 27, you might know that one already, but if not, you can double check it. Right? That'll give you 3. And then for x to the 6th, right, we talked about this a little bit earlier, but what you have to think of in this case is what value of x when I cube it comes out to be x to the 6th. Well, power raised to a power, you multiply. So it's 6 divided by 3, basically. That gives you your little answer. It's going to be an x squared right there. So that's recalling some information from that, your Algebra 1 skills, and we'll practice that more later as well. All right, let's take all those values and apply them. So since the first term was 125, into the parenthesis, the first term is the 5, and then plus second term was this, so the 3x squared is going to go second. So be consistent with that. It doesn't matter as much for these sum ones, but it will when we talk about difference in a moment. All right, into the second piece of it, right? Then what we have is the first term squared, so 5 squared, minus the product of the two, so 5, and then times 3x squared, and then plus the last part squared. So I'm going to put that in parentheses to make sure I square the whole thing. All right, now let's clean it up. This will give me 5 plus 3x squared. 5 squared is really 25. The product here would then be 15. X squared. And now 3x squared means I square both parts. So the 9 and then x squared, power raised to a power, I multiply. So it's x to the 4th. This crazy looking thing is that in factored form, right? I would say 99% of the time, once you factor it, as long as you took out a GCF beforehand, if there was one, this should not factor any further. So once you get it to here, you are done. All right, let's talk about one last thing, and that is the difference of cubes. The good thing is, once you learn that little system, you only have to make one tiny little adjustment for the difference of cubes. So if I give you x cubed minus y cubed, well, I'd still take the cube root of each part, which would be the x and the y, because it's minus this sign. The first parenthesis is going to carry that same minus. So whatever sign is here always carries into the first parenthesis. As for the rest of it, it's still the first part squared. It's still the product of the two. And then it's still the last part squared. The signs are what are going to change. So there's only ever one minus sign in the problem. So if the minus sign is in that first parenthesis, then the other two end up plus. So just the signs change. And so minus in the first, plus plus in the second. All right, so let's do one last practice one with this guy. So we did, or actually we can kind of highlight this too. So for example 3, Last one. If I throw at you, what could we put here? Oops. Let's go with 216 a to the ninth minus 1. All right. First things first, you have to make sure it's different to perfect cubes. So grab your calculator, if need be, and take the cube root of that thing. So if we go to math, cube root, we're good to go. If it's not a cube root, then it's not difference of cubes. So easy. The fact that the exponent is a multiple of 3, that's helpful there. So when we go to take the cube root of each piece of this, we already figured out that's 6. And then the rule is basically take the exponent and divide it by 3. Because if you can think in the other way around, you'd be saying a to what power when I cube it comes out to be 9? Well, it'd have to be the third power, because 3 times 3, that would give me 9. So this is going to be 6a to the third. The cube root of 1 is just plain old 1 right there. All right. And so now when we go to set this up into the first parenthesis, we'll go the 6a cubed minus 1. Into the second parenthesis is the first term squared plus the product of the two. So 6a cubed times 1 plus the last term cubed. Right? And when it's ones, yeah, there's not a lot of work to show, but you still want to think about it. All right, so finish it up. This is 6a cubed minus 1. If I square all of that, that'll give me 36. 3 times 2 gives me 6 power. And then plus 6a cubed plus 1. And that's it. All right. Thanks for watching, guys. Go answer that post-video question, and then we'll do some more practice together tomorrow in class.